In this video, I want to have a look at linear relationships. So a linear relationship is any relationship between two variables or unknowns where if we graphed it, it would give us a straight line. A linear relationship is always going to have an equation that looks like y equals mx plus b. So that m there tells us the gradient of our straight line, and the b tells us the y-intercept. The first example that I want to have a look at is this one. So it says Alex is organising a party. It's going to cost $300 to hire the function room, and then it's going to cost $70 per person for food. So if we write an equation for that, if we use C for the cost, it's going to cost $70 per person. So it's going to be 70 times the number of people. And I've just chosen C and N. You could use different letters. So 70 times the number of people plus that $300 as a one-off for the hire of the function room. So we actually gave these, that C and the N, our unknowns, we give them names. That N is called an independent variable. And the C, the cost in this case, is called the dependent variable. And that's because the cost is dependent on the number of people that come. If we wanted to graph this relationship, there's a couple of different ways we can do it. One of them is using a table of values. So if we're using a table of values, we're going to have our n, so our number of people, and we're going to pick some values for that. So we're picking values for our independent variable and then calculating what our dependent variable would come out to be. So it's up to you what values you pick. You probably want to do at least 3 to make sure they're coming out to be a straight line. If we're thinking about a function, let's go 60 people, 80 people, 100, and 120. So for each of those values, we're going to substitute them into the equation that we've got and calculate C. So for 60 people, it would be 70 times 60 plus 300, which would give us 4,500. Oops. For 80 people, we're going to go 70 times 80 plus 300, which would give us 5,900. For 100 people, we're going to go 70 times 100 plus 300, which would give us 7,300. And for 120 people, we'd have 70 times 120 plus 300, which would give us 8,700. So we've got these 4 values now, and we can use those to graph the straight line that represents this situation. All right, so I've drawn my axes up here. Along the horizontal axis, we're always going to have our independent variable, so that's our number of people. And up our vertical axis, we're going to have our dependent variable, which in this one is our cost. So we're going to put in, I've made our axes so they'd be 20 people each. So we're going to have 20, 40, so 60s here, 80, 100, and 120. It's a little bit squishy. And up the side, we've got to get up to 8,700. So let's go up by 2,000. So we'd have 2,000, 4,000, 6, 8, and 10. So now we're going to plot those 4 points. So 60 people was $4,500, which is about here. 80 people is 5,900, which is just below that 6,000. 100 people is 7,300, which is about here. And 120 was 8,700. Now, obviously, when you're doing this in your books, you've got grid paper, it's all measured out properly. It's much harder for me to do on here, but you can see that they form a straight line. If you graph your points and one of your points ends up, say, up here somewhere, and you'd have to go like that, you know you've made a mistake somewhere. So then we're going to draw in our straight line through those points, join it onto our axes. So that's the linear relationship that's representing this situation here. The second example that I want to have a look at is this one, where we've been given a table of values and we want to find the linear equation that describes this relationship. So we know, because it's a linear relationship, that it's going to have an equation that looks like y equals mx plus b. So m is our gradient and b is our y-intercept. So we need to find both of those values. So we know that the gradient of a line is the rise over the run. And often we've been reading that off a graph, so looking at how far it's moved up and across. In this one, because we've just got the values, rise is like the change in the y values, and the run is like the change in the x values. Oops, change in x. So what we're going to do, we're going to pick any two of the points, it doesn't matter which ones, and we're going to find the difference in the y values and the difference in the x values. So if we pick these first two, again, you could pick any combination of 2 points and it'll work. We're going to find the difference in the y values. So in this one it would be 11 minus 2, divided by the difference in the x values, so 5 minus 2. So that would give us 11 minus 2 is 9, and 5 minus 2 is 3, so 9 over 3, which is 3. So we now know that that m is 3, so our equation is looking like y equals 3x plus b. So we found part of it, we're halfway, but now we need to find what this b is. So our y-intercept, sometimes if you've got a table of values and it's got an x value of 0, you can just read off straight away what the y-coordinate is, because when x is 0, that's going to give you your y-intercept. In ours, we don't have that. So what we're going to do is we're going to pick any of these points and substitute in x and y, and then solve it to find b. So again, it will work with any of them, but let's pick that first one just because they're smaller numbers, so it's a little bit nicer to work with. So y is 2, so it'll be 2 equals 3 times x, which is 2 as well, plus b. So 2 is equal to 6 plus b. So then to get b on its own, we'd subtract 6 from both sides, and we'd end up with minus 4. So that means the equation of our line is going to be y equals 3x minus 4. Now at this point, it's always a really good idea to go back through and substitute in all 3 points into that equation and double check that they all work. Alright, so that's a few examples of linear relationships and how we can use tables of values to solve problems.